So let's consider the grains and primary pores, and let's talk about this word grain. In this field of sedimentary petrology, grain has a very specific meaning. It means that it's a particle. It's something that at one time in its history had an independent life. It's something that could roll around in a sedimentary environment. This differs from how this term is used in igneous or metamorphic petrology. You may hear people talking about grains in a granite or a grain of chlorite in a schist. And that's really different from how I'm using it here. And a pore, of course, is a particular void space in a rock, and as we will discuss later, as you get to smaller and smaller and smaller sizes, the definition of pore becomes a little shaky. And porosity, of course, is a bulk property, and there's typically, in petrology, we measure it as a volume %, but in many engineering applications, people talk about this void ratio of the volume of the pores over the volume of the solid. So, here's some examples of some primary pores. This is, on the left, is a kind of model where my colleague Earl McBride took some marbles, all the same size, dumped them in a Tupperware dish, filled it full of epoxy, and I made a digital representation of the slice. And the pore space here makes up about 43%, the blue, and that's really close to the observed porosity in sands. Of course, this is a more realistic depiction. Sand grains are not spheres, and when you stack them up, you get very irregular spaces. Here's an even more realistic depiction. Grains are not all the same size, and they're not all the same size. They're not all the same composition, and the spacing between them, the primary intergranular pores, can be modified by compaction. So can evolve. And another important point to make here is that the size of the grains and therefore the sizes of the spaces do not impact the intergranular volume. That whether the grains are big or little, you still get the same 43%, but the implications for permeability are obviously really, really different because fluids are trying to flow through much smaller pores.